Hello! How are you guys doing? In this video we will be solving polynomial inequalities and graphing them. In the past we have solved and graphed inequalities, but they were all parabolas, alright? They were quadratic. So now we're going to take it to another level. Oh, there's a good old quadratic. Okay, we've done that before. But now we'll deal with cubics. Anything else? Another cubic, and we got a fourth degree, a quartic. We're even going to do one where we make up one of our own. So that'll be fun. Alright, so let's see what to do. For each of these, you have to decide whether you want to do it graphically or if you want to do it by doing test values. Alright, some students prefer it one way, some students prefer it the other way. I am a visual thinker, so my tendency will be to use method 2 because I can do it much faster. But I'm going to show both ways, so you decide which way you want to do. Alright, I'm going to do problem number 1 both ways, alright, and then after that I think I'll just switch back and forth or something like that. But first, let me go ahead and do it using method 1, which is find the zeros and then do test values. Okay, test an x value in each interval to find the solution interval. So I'll do method 1 first. So alright, so first I have to find the zeros. So I would find that by setting each one of these equal to 0. Hold on. So that's just going to be x equals 0, x plus 1 equals 0, x minus 1 equals 0, and x minus, x minus 3 equals 0. Okay, so that's going to give me x equals 0, x equals -1, x equals +1, and x equals 3. So these are the zeros of the function. Okay, so let me go ahead and set up the graph. Okay, because we need a number line for this. Alright, so let me get my number line started. I guess that's going to go over here where the answers go. So let me put this over here. Alright, I'm just getting ready for my answer. Alright, so we'll put the answer over there. Okay, but so far I've got these x-intercepts. Alright, in order it would be -1, 0, 1, and 3. So let me put those on the graph now. Okay, so I've got -1, 0, +1, and 3. Is that right? Yep, those are my zeros. Now, I'm going to graph these as dots. Should I use open circles or closed circles? I am going to use closed circles because it's or equal to, alright? These values are the values where the function is equal to 0. So we want the equal to, so we will use closed circles to include the endpoints here. So closed circle, closed circle, closed circle, and closed circle. Okay? Now, please understand that these zeros have divided the number line into 1, 2, 3, 4, 5 zones. And I'm going to color them for you if I can. We have the yellow zone. What else we have? We got the pink zone. We got the purple zone. We got the gray zone. And we got the green zone. Okay, 5 zones. We need to do a test value in each one of these zones. Alright, what test value do you want to use for the yellow zone? Okay, how about -2 for the yellow zone. Alright, what about the pink zone here? We'll have to do a decimal, alright, between 0 and -1. So how about -0.5? Okay, for the purple zone, we will also need a decimal. Alright, this time positive 0.5 would work. For the gray zone, we could use 2, would be a logical choice. And for the green zone, we could use 4. So let's use these values for our test values. Okay, so let's start with -2. Okay, so if I do a test value of -2, let's see, and I'm going to organize this horizontally so it's the only way there's space. Okay, and I guess if I want to really be official about it, I could say f at -2 would be really the way to go. So f at -2 would look like this. It would be -2 times -2 plus 1 times -2 minus 1 times -2 minus 3. And we're going to find out if that's greater than or equal to 0 or not. Okay, so now if you can comfortably work this out by hand, that's great. Some of you need to use a calculator for this stuff because you just can't do it. I don't know what to tell you at this point. Use a calculator. Okay, so there I've typed in this entire thing, which is always an option, and we get 30. Okay, so this is equal to 30. Now the question is this greater than or equal to 0? And of course the answer is yes, 30 is greater than 0. So that means -2 is a solution. That means everything in the yellow zone is a solution. And we will show that by drawing an arrow for the yellow zone. Okay, so we need to do that 4 more times. So let's do -0.5, representing the pink zone. So we'll do f at -0.5. So that's -0.5 times -0.5 plus 1, -0.5 minus 1, -0.5 minus 3. Right? 1. Yeah, there it is. Let's find out what this is. Alright, I'm definitely going to just type all this in my calculator. Alright, I've typed it all in, and I get -0.13 whatever. Okay, the details aren't important. It's approximately -1.3. Alright, I guess I should make this a wavy line for approximately. But the point is this greater than or equal to 0? No, it is not greater than or equal to 0. Okay, it's a negative number. So that means that the pink zone, these numbers are not solutions. So I'm just going to leave that blank. We'll leave it blank. Alright, and now I'm going to move on to the purple zone with a 0.5. Alright, so I'm going to do f at 0.5. So it's going to be very similar to what we had before, only with 0.5 this time. Alright, let's see what that is. Alright, it's all typed in here. Positive 0.9, close enough. Okay, so approximately 0.9. And the question is this greater than or equal to 0? Yes. Alright, it's a positive number, so that is greater than 0. That means these purple values are solutions, and I will show that by putting a segment in here. Okay, those are solutions. Okay, how about the gray zone? Right, with the 2 is our test value. So let's do that. Okay, so I'm doing f at 2. So that'll be 2, and then 2 plus 1, and then 2 minus 1, and then 2 minus 3. Okay, you should definitely be able to do this without a calculator, because this would be like 3, and then 2 minus 1 is 1, and then that's negative 1. Okay, so I've got 6, and then the negative 1 makes this negative 6. So is that greater than or equal to 0? No, it is not. Okay, that means this gray zone has no solutions. So we won't, we'll just leave that blank. So let's test the green zone with the 4. Alright, so our final stop, man. F at 4. So this will be 4. Okay, so this would be 5 and 3 and 1. Okay, so 4 times 5 is 20, and 20 times 3 is 60. Okay, is this greater than or equal to 0? Yes. So that means the green zone has the solutions. So we will go ahead and show that the green zone is full of solutions by drawing an arrow for the green zone. Okay, so this blue graph represents a graph of the solution set. Alright, I can get rid of these colors now. Okay, let me just erase this too because it's not really part of the answer. Alright, so this is a graph of the answer. You also need interval notation and such for each one of these branches. So this part over here is from negative infinity to negative 1. Right? Included, so closed bracket. Alright, use union between these. This is from 0 to 1. Okay, and then this goes from 3 to infinity. Okay, so that is the answer. Alright, that took kind of a long time. Okay, and that is how you would do this problem if you're going to do the test value method. Now, let me show you how to do that same problem. I'm going to do the same problem over again using the graphical method. Alright, here's the same problem using the graphical method. The first part is the same. You still need to find the zeros. Alright, you still are going to plot them on a number line like this. Now, if you're going to use the graphical method, though, you need to make another number line, okay, over here in the work area. So here's another number line that we will use in the work area. So so again, here's my negative 1, my 0, my 1, and my 3. Okay, so I've got, these are my x-intercepts. So I will go ahead and show those. Okay, these are my x-intercepts. Okay. Now, this is a degree 4 function. Okay, this is degree 4. Let me just keep this blue for a second. Okay, you can just count the x's. 1, 2, 3, 4. Alright, this is degree 4. Now, a degree 4 function is sort of like a W shape. Okay, it's like this. Okay, and it's got a positive leading coefficient, so you know it's going to be an upward facing W like that. Let's move this over a little bit. Okay, so let's just draw an upward facing W with these x-intercepts. Alright, so if you do that, it's going to be something like this. Alright, got a little crazy there at the end. But you get the idea. Okay, so there's an upward facing W with these x-intercepts. Now, we want to know where is the function greater than or equal to 0. Okay, so we are interested in the part of the graph that is above or equal to 0. Alright, of course, the places where it's equal to 0, those are the x-intercepts themselves, so keep that in mind. But where it's above 0, alright, let's highlight that in green. It's going to be above 0 everywhere it's above the x-axis. So it'll be above 0 here, and here, and here. Okay, so here's where it's above 0. Okay, so in other words, it's above 0 in looking at our zones over here. It's above 0 in this first zone, alright, to the left of -1. So we could just go ahead and draw that in. Alright, it's above 0 over here. And let's see, where else is it above 0? It's above 0 between 0 and 1. So you could draw that in. And it's above 0 to the right of 3. Okay? Now to me that is 10 times faster than doing all those test values. So if you're a visual thinker, this is definitely the way to go. And then just like we did before, we once you have this, the interval part is the same. -∞ to -1, 0 to 1, 3 to infinity. So I think I'm going to just stick to the graphical method. It's just, the other way is just too tedious. I showed it once, so if you like the test value method, you see how to do it, but I'm going to do it this way from now on. Okay, and even though I've only done one problem so far, this video is already 18 minutes long. So I'm going to end this video now, and the rest of these should go much faster. So I'll see you for number 2 on the next video.